Hello, here we've got our second lesson this term on the driving question, how do I order decimals? So as a starting activity, what I'd like you to do please is put the correct sign, the lesser than or the greater than sign, in between those two numbers. So when you're ready, pause the lesson, answer the questions, turn it back on when you're ready for the answer. So here's our first set of answers. The first one is a greater than sign, B is a less than sign, and C is a greater than sign. Remember that the open side of the V points to the largest side. Okay, if you need to pause the lesson at this point to do any corrections, please do so. And now we'll move on. So the first part of this lesson is going to be on significant figures, or rounding to significant figures. A significant figure is the first non-zero digit in the number, counting from the left. So you can round numbers to a certain number of significant figures, which we call SF. The first significant figure is the one with the highest place value. It's the first non-zero digit in the number counting from the left, because that will have the highest place value in terms of hundreds, tens and ones, and so on. I'd like you to pause the lesson now and write down that definition, please. And once we've done that definition, it's time to have a look at these worked examples. So I've written them here as well, they're exactly the same. Round these numbers to the number of significant figures shown. So the first number, 34.069, and we're rounding this to 4 significant figures. So we count the first 4 figures. 1, 2, 3, 4. Notice we don't count the decimal point, it's not a digit. We count this 0 because it's after the first non-zero number. If it was at the beginning of the number, it wouldn't count. But because it's in the middle of our count, we count it. Then, so that's my 4th digit, I then look at my next number, it's a 9. So I'm looking at this number, and what do I round 0.0692? Is that closer to 0.06 or 0.07? Well, it's closer to 0.07. So my answer is 34.07, 4 significant figures. I know it's 4 numbers because there's 1, 2, 3, 4 numbers there. My next one, again, I've got in this case I've got a number that's a pure decimal. There's no whole numbers in it, and we're rounding this to 3 significant figures. I don't start counting here or here. I start counting on the 4 because the 4 is the first non-zero number. 1, 2, 3. So the last number is the 1. I look at the number after it. It's a 2, which means I ignore it. So I end up with 461. However, when I write it down, I write down the zeros in front as well because I can't change this place value. Remember, this number is 4 hundredths. So when I write it down over here, it must be 4 hundredths. To make it 4 hundredths, I've got to put 0.0 in front of it. That's why it's written like that. Then we go on to my next number up here, 12,575, rounded to 2 significant figures. So my first figure is a 10,000, my second figure is 1,000, my third figure is 100. It's my hundreds figure. So 2 numbers, 1 and 2. I look at my next number, it's a 5, so I'm going to round that to a 3. But this 3 isn't 3. This number isn't going to be a 3. It's going to be a 3000. So I must add the zeros in to make this number up to the thousands. I can't just write the 1 and the 3. I have to get the place value correct. So I add enough zeros to make my place value correct. And that's the case always with significant figures. Okay, if you need a bit more time to write it down, pause the lesson and return back to it when you're ready. So now, I've got some questions for you. Round each of these numbers to one significant figure. Okay, pause the lesson, return back when you're ready for the answers. Excuse me a second. Oh, that's better. So, I've done these already. I just got a little bit ahead. So the first one, 328 to one significant figure. I'm looking at hundreds. So the nearest 100 to 328 is 300. My next number, what the nearest, the biggest number, the first number is 1,000. So I'm rounding this to the nearest 1,000. The nearest 1,000 to 5,900 is 6,000. The next number, I'm rounding to the nearest 10 of thousands. The nearest 10 of thousands to 21,000 is 20,000. And lastly, the final one, I'm rounding to tenths, and the nearest tenth to 0.63 is 0.6. So that gives us my answers there. If you need some time to write down your corrections, please do so now. So, in the next case, what we need to do is round each number to the number of significant figures shown. So in each case we're going to have a slightly different one. The first one is to 4 numbers, the second is to 1, third is to 2, the final one is to 3. So each one is a slightly different number. So when you're ready, pause the lesson, carry on when you're ready. Again, these are questions that I prepared earlier. So my first one, 4 significant figures, 1, 2, 3, 4. You can always count the numbers, just start counting at the first number, keep going. And that would be 60.25. The second one, 1 significant figure, but I don't start counting till I reach the 5. I look at the next number, it's a 7, so that rounds up to 0.006. The next one, 2 significant figures. We're looking at 364,000. I'm not really bothered about the next numbers. Rounded to the nearest 10,000, that's going to be 360,000. Just with lots of zeros. And the last one, some of us may recognise this number. This number is a very, very famous number. This is the beginning of the number pi. And it begins 3.14 and carries on. Rounding to 3 significant figures, the first 3 numbers, that gives us 3.14. The next number is a 1, so I ignore it, so 3.14. I hope everyone is getting these correct. If you need to do a correction, please do so now, and then rejoin when you're done. Okay, my next set of questions is a twofold question. So the first thing, round each number to two significant figures. So you've got a little bit more practice to do. Then the second part, do you always, never, or sometimes get the same answer when rounding to two significant figures or two decimal places? So, let's have a look. So, pause the lesson, answer those two questions, please. Return back to the lesson when you're ready. So, for 1 or A, 2.2, B, 7.5, C, 5.1, D, 6.2, E, 45, F, 0.86, and G, 9.0. All two numbers. So, in terms of reasoning, do you always, sometimes, or never get the same answer when rounding to two significant figures and two decimal places? The answer is sometimes. The times when you get it are when you're looking at a number where the first non-zero digit is a tenth. If you do that, you will get the same. So it's only on a few occasions. Any numbers that are any bigger, obviously, it's just not going to work for. So it is very much sometimes and relatively rare. If you've got everything like that, that's great, carry on. Otherwise, please write any corrections that you need to, and then rejoin the lesson when you have finished. Okay, let's just spend a bit of time studying this. This is just a place value chart. So we've got, starting on the left, which is the highest value, we have tens, ones. The next column is for the decimal point. Not convinced that should be a column. I'd be quite happy with a line, really. Then 1/10th, 100th, 1,000th, 1/10,000th, 1/500,000th, and finally 1,000,000th. Each one gets 10 times smaller than the number before. This is really, really important when we come on to ordering decimals, because if the number in the tenths column is larger in one number than the other, that number is going to be bigger, regardless of anything else. So when we're comparing numbers, all we have to do is start at the very left of the number and work our way across. So first off, we look at the first numbers. We look at, say, if the first number is a unit, is a 1, we say, right, which is the number with the biggest 1, then which is the number with the biggest tenth, and so on. So let's have a quick look at the question based on this, and see how we do. So first thing we're going to start with is a few more less than or greater than. So we have 5 questions, and you have to decide each time which answer is the biggest. When you're ready, pause the lesson and start work. Okay, so let's have a look at a few of these as I work my way through. So in these first two numbers, forget the fact I've already written the sign down, but let's compare. 4 and 4, that's not helping us. 3, 5. So this is 3/10, this is 5/10. This number is bigger. 5/10 is bigger than 3/10. Doesn't matter what happens after that, this is going to be bigger. So this number is greater than this number. That's why I've got the greater than sign in. Start on this one. 0, 0, 2, 2, 4, 4, 5, 3. As soon as I see that 5 there and the 3 there, that means this number is bigger. So this number is the greatest. So this number is less than this number is greater than this number. The next one, 9, 9, 6, 6, 2, 7. Comparing the place value, this has got the highest place value in the hundredths column, so this number is the biggest. Similarly with this one, 21 is exactly the same. 0, 0, 2, 2, 9, 1. Even though there's another number on the end here, there's 1, 1. That's totally irrelevant. 9 is bigger than 1, so this number is biggest. And the same thing over here. 6, 6, 3, 3, 2, 2, 1, 1, 0, 0, 8, 7. 8 is bigger than 7. This is the biggest number. Even though there's another number on the end there, it doesn't make any difference at all, because we're after the decimal point. So this is 100,000, tens, hundreds, thousands, 10,000, 100,000. We have to go down to the 100,000s with this one, but in the end this number is bigger when we get to the 100,000s. If that isn't what you've got, can you change it now please, and maybe perhaps mark on where it changes. Okay, here we have a set, or 1, 2, 3, 4 sets of decimal numbers that need to be put in order. Remember, when you're doing this, start with the first number, which is start with the number on the left and work your way across. So in this first example, you've got a mixture of ones and noughts first. So any number that starts with a 1 is going to be bigger than any number that starts with a nought. So you can already start sorting out by them. Okay, when you're ready, pause the lesson and start work. Okay, so here we have them. Here's my answers here. You can check, but I'm just going to go through this first one and then you can work your way through them. So I look at these numbers. I've got a 1, a 0, a 1, a 0 and a 0. So straight away I know that the biggest two numbers, without even looking anywhere else, must be either this number or this number. I then look at the tenths. I only need to look at this one and this one. This has got no tenths, this has got 2 tenths. This is the biggest number, 12.232. I don't have to look at the rest, I can do that already. I know that this one is the next biggest because it's got a 1 in it, so that one goes down next. Now I've got to look at these three numbers. There's no point in looking at the 0. I know that they've all got 0, so now I'm going to look at the tenths. No tenths, 2 tenths, 1 tenth. It's this number. This number is next. 0 to 200. Then I've got these two, so this has got 1 tenth, this has got no tenth, so this one followed by this one. And that's how I go through them all. I work one number at a time. So on my next one, I'll just go through them now. 4.735, 4.23, 4.227, 4.051, 3.924. Notice that even though this is only 0.23 and this has got 3 digits and this has got 3 digits, this one is biggest because the tenths are bigger, or in this case it's the next number is bigger, but this number is bigger than both of those two, because this has got 2 tenths, this hasn't got any tenths. This has got 3 hundredths, this has only got 2 hundredths. The next one, so we've got 2 sevens followed by some zeros, 7.09, 7.0932, 7.001, 0.749, 0.7113, 0.0732. And lastly, 25.645, 25.62, 24.833, 24.4570, and 22.961. Okay, if you need a little bit more time to mark that, or you need to write some corrections down, pause the lesson, and return back to it when you're ready. Okay, so a similar sort of thing here, but we've got a mixture. We've got positive and negative numbers. Now on this number line, any number that is to the right is bigger than any number to the left. So the numbers are at their biggest here and their smallest here. That means minus 0.2 is bigger than minus 0.3. If you want to think of this in a different way, think of it that it's further from 0. The further you go from 0, the bigger you become, which is exactly the same in both directions. So the further you get from 0, effectively, the bigger you become. And, or if you prefer, when you took the minus number, the more of a minus you are. The more of a minus you are, the further away from 0 you are, the lower you are. It's like if you look at temperatures, -1 is cold, -10 is really cold, and so on. So the further away you go, the bigger the minus becomes. Effectively, the smaller the number is. So halfway between minus 0.3 and minus 0.2 will be minus 0.25. Nearly all the way to minus 0.3 would be minus 0.29. So the numbers work in exactly the same way, but going this way. And minus 0.25 is smaller than minus 0.2. It's also bigger than minus 0.3. So bear that in mind as we're working our way through our next set of questions. So pause now, answer the questions, turn it back on when you're ready. So, minus 0.2 is bigger than minus 0.3, as we can see. Minus 0.3 is less than minus 0.29. Again, as we've just seen, it's actually smaller, it's gone further away. Minus 2.39 is bigger than minus 2.9, because that would be closer to minus 3, wouldn't it? And lastly, minus 9.3 is less than minus 9.23, because it's getting further and further away from 0. Okay, if you're happy with those, move on. Otherwise, pardon me, answer or write your corrections. Okay, right, each list of numbers in ascending order. That means from the smallest to the biggest. So the first thing we have to do this time is find the smallest number, then the next biggest number, and so on. Remember, all negative numbers are smaller than all positive numbers. And just work your way down through them, please. Okay, when you're ready, pause the lesson and work your way through them. Okay, so this is the order that you should have written them down in. So for A, minus 4.6, minus 4.2, 2.46, 2.6. That should have been our first set of numbers. Second set of numbers, minus 10.53, minus 10.5, minus 10.3, 10.35, 10.5. C, minus 0.77, minus 0.7, minus 0.07, 0.07, 0.7. D, minus 0.845, minus 0.149, minus 0.135, minus 0.125, minus 0.0122. E, minus 0.0342, minus 0.0325, minus 0.0309, minus 0.0324, oh sorry, 0.0324, not a minus. And lastly, 0.033, that's the biggest number there. And finally, F, minus 5.5005, minus 5.055, minus 5.05, 5.0005, 5.0505. Wow. Okay, hope you got all those correct. If you didn't, pause for a moment, check your answers, try and understand where you went wrong. Okay, challenge question. Write two sets of numbers in descending order so that A starts with 0.122, then has a number with 2 decimal places, then has a number with 3 decimal places, then has a number with 3 significant figures, and finishes at minus 0.112. For the next one, start at minus 6.007, then have a number with 2 decimal places, then have a number with 2 significant figures, then have a number with 3 decimal places. Okay, now when I do this, which I will be doing in a minute, obviously I'm going to be writing my own numbers down. They might not be yours, but let's make certain when you mark yours that they follow the same rules as mine do. Okay, pause the lesson and then be ready to resume after you've done your work. So my first number, I know that's going to be 0.112. And these numbers are going to be in descending order, so it's got to be smaller than that, and it's got to have 2 decimal places. So I chose 0.11, 2 decimal places. My next number has to be a number with 3 decimal places, and it's got to be smaller than those, so I'm going to choose 0.1008, 3 decimal places, and lastly a number with 3 significant figures. Okay, and to be honest with you, I'm going to keep it very similar. To give it 3 significant figures, I'm going to do 0.106. That has 3 significant figures. I haven't gone into minus numbers. I will do what I have to next time. And then finally, minus 0.112. Your numbers can be anything. So long as they fulfill those rules, it's absolutely fine. So as long as your first number has 2 decimal places, like this one, 1, 2, your next number has 3 decimal places, like this one, and your final number has 3 significant figures, or like this one. 3 significant figures just means 3 decimal places, really. It's quite easy in this case. So, B. My first number is minus 6.007. Now I need a number with 2 decimal places that is between 6.007 or minus 6.007 and minus 6.7. Well, the number that I am going to write with 2 decimal places is minus 6. I could write anything there because it's only after the decimal. 5, 7. That number has got 2 decimal places. My next number has to have 2 significant figures. So the first 2, I've only allowed 2 numbers. So I'm going to make this, and it's got to be more than minus 6.57, and it's got to be less than minus 6.57 and more than minus 6.7. So I'm going to write minus 6.6. 2 significant figures and 3 decimal places. I'm going to have minus 6.652. It's bigger than that, and then finishing it off with minus 6.7. Again, you can have any numbers that you want in there, so long as they follow the rules. If you need some time to redo your answers, or you just want to copy down mine, as long as you understand why, that's fine. And lastly, a reflection. Again, there's nothing really for me to write about this, but in a session, if you're doing lots of work with decimals, imagine someone who'd never seen a decimal point before. They've never done decimals. How would you describe it? Or define it? What is it? What does it do? How would you describe what it does? Write a description in your own words. And obviously we can't do the last bit, which is a shame, because I'd be really interested to see what people have done. If you are in one of my Year 8 classes and you're working your way through this, I'd be really, really pleased if you could write your description up on the class board. If you could just put it up to the class so we can actually see what the descriptions are. I think that would be fantastic. Perhaps other teachers, other teachers might want it as well. But I'd be really interested to see this. So yes, today, this final slide, you've actually got a bit of work to do. I do want to actually see some work written up on this. Just a description of what the decimal point is and what it does. So that's the end of today's lesson. Thank you very much. I hope you enjoyed it and I hope you learned something. Goodbye.